Hi everyone, in this video we are going to discuss how to implement a decision tree in Python. At the end of this video, you are able to implement the decision tree algorithm like this. This video is a part of an introduction to classification series. So if you want to see the complete playlist, I will provide the link in the description. Now let's get started. This is the dataset we are going to use. As you can see here, we have diseases column, where we can see some of the diseases like fungal infection, allergy, etc. And we have some symptoms column which relates to that particular diseases. Now what we are going to do is, we are going to build a decision tree classifier using this dataset. Let's start with importing the pandas library as PD. Next, we need to import our dataset into our notebook. Our dataset is in the form of CSV, so we are going to use pd.readcsv command to read our dataset. Now we are going to use data.head command to see the top 5 rows of our dataset. As you can see here, we successfully imported our dataset. We all know that machine learning algorithms work only on numbers. They can't understand labels. So what we have to do is, we need to convert these particular labels into numbers. One of the ways of doing is to use the label encoder. So from sklearn.preprocessing, we are going to import label encoder. Now I am going to create the objects of this class. I have 6 columns which consist of labels. So I am going to create 6 objects. First is le_disease. And second le_symptom1, and next symptom_2, 3, 4 and 5. Now in our data frame, we are going to create a new column disease value. We call fit and transform method on our disease column. Similarly, we need to create column for 5 symptoms too. Now if we look at our dataset will be in this form. As you can see here, in the disease value column, 1 indicates fungal infection, 0 indicates allergy and 2 indicates GARD. Similarly, the labels of 5 symptoms also encoded into numbers. Now, we need to split our dataset into independent variables x and dependent variables or target variables y. Independent variables do not depend on others, whereas dependent variables depend on others. All 5 symptoms belong to the category of independent variables. So we are going to use data.ilog command to get those 5 columns. Now if I execute x.head command, we can see only those columns. Similarly for y, using this command y=data.ilog, we can get this last column. Now if we execute y.head, we can see only the dependent column. Now we are ready to train our classifier. So from sklearn, we are importing tree module. Next, we need to create decision tree classifier object. Now we can train our model using the command model.fit. I am going to use x and y here. Here it uses criteria as Gini. If you want to know what is Gini, please check my previous video. Now my model is ready to go. Let's do some prediction. Let me predict a person's disease who has stomach pain, acidity, vomiting, chest pain and cough as symptoms. It gives us 2. This is one way of predicting. Other way is by using train test split method. Now let's use train test split method to split our dataset, and let's see how accurately our model is predicting when the data is splitted. So from sklearn model selection, we are going to import train test split module. In the previous case, what we did is, we taken the entire dataset and we fitted into the algorithm. But now, what we are going to do is, we are taking only some part of the dataset and we are naming it as training dataset, and the other part will be testing dataset. Using this command, we can do that. Here, the number indicates in what ratio we are splitting the dataset. For example, if we take test size equal to 0.2, this will split the data in the ratio of 80:20. That means 80% of data acts as a training data and remaining 20% acts as a testing data. In our case, we took test size as 0.3. That means 70% as training and other 30% as testing. Now, using this command, we are fitting the training dataset into the algorithm. With this command, we can pass a testing dataset to predict the testing dataset labels. We can compare the predicted values and the original ones, keeping side by side by creating a data frame. Here is my output. Here, I can clearly see that almost in 90% of the cases, the algorithm is working fine and giving the correct cases. Now, if we calculate the score of our model, it is showing 0.88, which indicates 88% of the cases the algorithm is working fine and giving the correct labels. That's it for the video, guys. I hope you have learned something from this video. If you have any doubts, please leave it in the comment section below. I will get back to you as early as possible. If you like this video, please do like, share, comment and subscribe. It means a lot to us. Thank you. Signing off.